All. Now in this particular video we will see variables in C programming. Now let's see what is the definition of variable. A variable is a memory location in which a value can be stored. So for example, observe this line, int space a is equal to 10. Here a means the variable name. Inside the variable a we are storing 10. That is the meaning of this line. So a variable is a memory location. So you can assume a variable is a box. Inside a box a value can be stored. It is a memory location, but a variable value can be changed during the execution of the program. For example, if you declare int a is equal to 10, it does not mean it is a constant. You can change later onwards. You can change a is equal to 15 later onwards. So that is the meaning of a variable value can be changed. Now let's see the identifiers. Before you name the variable names, there are certain rules. Those rules are known as identifiers. Now let's see the definition of identifiers. Identifiers are the names which are given to variables, functions, arrays and pointers. So any name if you see in the program, that is called a identifier. Identifiers we can generally give it to variable names and function names, etc. But there are certain rules for identifiers. You have to follow those rules in order to give the variable names, function names. So that is the meaning of identifiers. We will see the rules of identifiers in the next slide. So these are the important rules of identifiers. The first one is it can contain 0 to 9 digits, and it can contain small letters and capital letters, and underscore. Underscore is valid in identifiers. So these are the valid symbols in identifiers. So 0 to 9, small a to small z, capital A to capital Z, and underscore. Okay. So identifiers cannot start with digit, even though digits are allowed in identifiers, but identifiers cannot start with digit. That is the one point you should remember. And third point is special symbols like @ hashtag, dollar, white symbol. These are the special symbols you cannot use in identifiers. So special symbols are not allowed in identifiers. When it comes to keywords, keywords are the reserved words like for, while, do while. These are the reserved words. These are having special meaning, and we should not use keywords in identifiers. For example, for is a keyword in C language. You should not name int for is equal to 10. It is a keyword in C language. You should not use for as a variable name. So that is the meaning of keywords cannot be used as a identifiers. And the last rule is not a rule actually. But we will see identifiers length, that means variable length or function name length cannot exceed 31 characters, but most of the recent compilers are exceeding, I mean you can exceed the character length, but the recommended length, it should not exceed 31 characters, but this is not a strict rule. You can exceed 31 characters as well, but we should not exceed 31 characters. That is a standard they are following. In industry they are following 31 characters. We should not exceed 31 characters. These are the very important identifier rules. Several people are making mistakes while declaring variable names. So keep these rules in while giving the variable names. These are very important, to be honest with you. And now let's see some of the valid identifiers and invalid identifiers in C programming language. I have listed very few of them. One is ABC. ABC is a valid identifier. Now this is allowed. And when it comes to digits can allowed in identifiers, right? So ABC1 is equal to 40. Even 1 is allowed. So that is also valid. A underscore BC. As we seen in the previous slide, underscore is valid identifier in C programming language. So this is also allowed. Now let's see some of the invalid identifiers so that you will get a better understanding what is identifier means. Here int 1 ABC. Identifier cannot start with digit, but we are starting with digit. Not only one, you cannot use 0 to 9 as a starting letter of identifiers. So this is not valid. Okay. Now let's see some of the my space roll number. Space is a white space in C programming language. Space is not allowed as an identifier. So this is not valid. Okay, and int for, as I said previously, a for is a keyword in programming language. C programming, there are some keywords. For is one of the keyword, and you cannot use keywords as identifiers or the variable names. So these are the some of the valid and invalid identifiers in C programming language. Now let's see the keywords in C programming. Keywords are the reserved words which are having special meaning in C programming language. Thus, we cannot use keywords as identifiers. We should use in that particular context only. For example, const is a keyword in C programming language to define constants. A constant value cannot be changed during the execution of the program. A variable value can be changed during the execution of the program, but constant value cannot be changed. Once it is fixed, it is rock written. You cannot change it. And these are the some of the keywords, but in C programming language there are 32 keywords in C programming language. So these 32 keywords you should use in that particular context only. For example, when it comes to loops, for is a looping construct. You should use in loops only. You cannot use for as a what I mean to say is the identifier name. In previous slide, for I used as a variable name. You should not use like that. Now when it comes to other keywords like while, do while, these are also loops which we will see in the unit number 2. There are 32 keywords and these are case sensitive. What do you mean by case sensitive? Case sensitive means your lowercase letters and uppercase letters will be treated differently. For example, if you given ABC is equal to 10 and you have declared another variable called capital ABC is equal to 20, these two are treated differently. This is called case sensitive. Okay, so all keywords are case sensitive. That is the point here. Now let us see the data types in C programming language. So to put it simply, data type specifies the size and type of a value a variable can hold. Okay, for example, there are two types of data types. In some one is primitive data types and another one is derived data types, and our focus is only primitive data types as of now in this particular unit. When it comes to primitive is the inbuilt data types, that means built-in data types in C programming language. We have 4 major primitive data types. One is integer, that means we can store positive and negative and 0 as part of integers, and character. A character is a single alphanumeric symbol which is enclosed in single quotes. So generally we can store symbols as well as part of characters. It is a alphanumeric symbol. Okay, and float. To declare point numbers like 2.5, 3.5, we can store float data type. We can store those numbers in float data type. When it comes to double, it is a double precision, that means after decimal point. For example, in float we can store 3.56, and in double also we can store 3.56. And what is the difference between these two? What is the difference between float and double? In float, after decimal point we can get 6 digits of precision. Precision means accurate value. Without rounding up value, we can get 6 decimal places of accuracy. But when it comes to double, after decimal point we can get 15 to 16 decimal points as the accuracy value. That is the difference between float and double. And we will see derived data types in upcoming units. This is not the correct time to discuss. And let us see some of the very different types of data types as part of primitive data types. So character, and we are seeing different keywords here. One is signed and unsigned. These are very important to understand. Signed means we can store positive and negative, both we can store in signed, and unsigned means we can store only positive. That is the meaning of signed and unsigned. As part of signed we can store positive and negative, but when it comes to unsigned we can store only positive numbers only. So character size is 1 byte in C programming language, and the format specifier for character is %C. So there comes another question called what is format specifier. A format specifier is a a way of telling to the compiler in which format we are going to print that value. This format specifiers should be used in functions called printf and scanf. So these format specifiers should be used in these functions only, printf and scanf. Printf is a print formatted and scanf is a scan formatted. So printf is the output function which is declared in stdio.h, and as well as scanf is a input function which is declared in stdio.h as well. So when it comes to short, we can decrease the data type by using a keyword called short, and int short signed int means we can store both positive and negative, as I said earlier, and the byte stored is 2 bytes. For integer, this is %d. The format specifier which we are using as part of integer is %d, but we can use for %i also. Okay, and when it comes to integer, we can use %d, and when it comes to unsigned means we can store only positive, not the negative numbers, right? So unsigned means we can use %u as a format specifier. So these format specifiers should be used in a functions called printf and scanf only. Okay, so when it comes to long, there is a keyword called long. We can increase the particular data type size with a keyword called long. Previously we can decrease the size with short keyword, but with the help of long keyword we can increase the size of the data type. So long signed int means 4 bytes, and the format specifier is %ld. Okay, and unsigned long int means %lu. And when it comes to floating point data types like float and double is 8 bytes. But by the way, these are compiler dependent. What do you mean by compiler dependent? Compiler dependent means this is a platform. So there are 16-bit compilers and there are 32-bit compilers. So whatever you are seeing, these are part of 16-bit compiler sizes only. These are not part of 32-bit compiler. So in C language, the data type sizes can be vary depending on the platform you are using. To be honest with you, depending on the compiler you are using. If you are using 16-bit compiler, these values are appropriate. If you are using 32-bit compiler, these values can be increased. Okay, so these are compiler dependent. Okay, so float means 4 bytes, that means %f can be used, and double means %lf can be used. The size is 8 bytes. Okay, and there are other data types as well. Long int, we can store more number of bytes here, and the percentage, the format specifier is %lli, and when it comes to unsigned long int, the format specifier is %llu. That's it for today. We will see some of the programs tomorrow. Thank you so much for watching.